Good morning, friends. My topic is MEMS Microelectromechanical System. From the name itself, micro, it can be impossibly small. It is not even visible to human eye. It is this MEMS Microelectromechanical System is a miniature machine that is composed of both electrical and mechanical components. This can range in size from several millimeters to 1 micrometer. This MEMS are used to MEMS are having the ability to sense, that it can even sense signals, that is micro level signals. It can even sense micro level signals, control and actuate on micro scale, then generate effects on macro scale. That's an important point. That is, these devices, this miniature machine system or devices sense the signals, control and actuate in micro scale, then it generates the output on macro scale. While manufacturing this microelectromechanical system, it is used to describe both micromechatronic devices and processors. As we already told, it is having two components, electric component and mechanical component, but some MEMS do not possess or do not even have this mechanical parts, but they are considered as MEMS itself. Because these MEMS devices convert mechanical signal into electrical signals, so that they are referred to as transducers. These MEMS, in India we are calling it as MEMS, while in other countries it have several names, it have different names. In Japan it is commonly known as micro machines, and in European countries it is known as MST, that is microsystems technology. Then how it is made, how these MEMS are made. As we already told, it is having two parts, electronic part and mechanical part. This electronic part are fabricated using computer chip IC technology. So electronic parts are fabricated using computer IC technology, and this mechanical components are fabricated using this silicon, using sophisticated manipulation of silicon and other substrates. Then it is having four components: microsensor, microactuator, microelectronics and microstructures. First one is microelectronics. Microelectronics is considered as brain of MEMS. The component microelectronics is known as brain of MEMS. It is used to receive the data, process and makes decisions on how to start, how to activate the device, etc. And the data comes from microsensors. It is used to receive the data. For to receive the data, something needs to be sent the data. So this microsensors sends data, and this microelectronics receives that data, processes and then makes decisions. The next is microsensors. Microsensors are used to gather data from environment. That is, this microsensor act as eye, nose or arm that gathers data from outside the environment, not outside the environment, from the environment, and this gathered data are passed into microelectronics. Next, microelectronics for processing. For to receive data in microelectronics, for to receive data, microsensors sense data. Then this microsensors passes data to microelectronics for processing. Then it can monitor mechanical, thermal, biological, chemical readings. This microsensor can monitor these functions. The next is microactuator. It acts as a trigger. It acts as a external. It is used to activate the external devices. This microactuator is used to activate the external device, and this microelectronics will tell microactuator to activate device. Microelectronics, as we already told, this microelectronics makes decisions. So one such decision is when to activate the device. The next is microstructure. Microstructure, from the name itself, microstructure, it is very extremely small structure built onto surface of chip. The next, MEMS components. This we already told about this, microelectronics, microsensor, microactuator and microelectronics. Then how MEMS are constructed. It is having 4 parts. Then it is not like conventional mechatronic devices. This is manufactured like manufacturing IC itself, and integrated. These MEMS products are integrated and packaged together with ICs. It allows microsensor, microactuator, etc. Then advantages and disadvantages of microelectromechanical systems. Advantages: it is very small in size, so, and mass and volume is also small. It is also less. Then power consumption is low because of the structure. Maybe because of the structure, it is cheap in cost. It is easy to integrate into systems. And to modify a MEM, it is easy to modify a MEMS. We can modify a MEMS easily. Then these MEMS are having small thermal constant. Then disadvantages include designing MEMS is tough because of the miniature structure. We know that it is very small and it is difficult to, because of its complex procedures, it is difficult to design MEMS. Then applications. There are several applications using this this MEMS. One is building management system. It is used in building management systems. Then used to detect environmental changes, used in inkjet printers. In inkjet printers, this MEMS are used to control the flow of ink in that printer. Then it is even used in healthcare. So briefly, applications of MEMS are micro engines, inertial sensor, pressure sensor, optical MEMS and fluid DC MEMS. Then the difference between MEMS and IC. MEMS is a 3D complex structure. MEMS is a 3D complex structure while IC is a 2D structure. Then next, we know that in IC, transistor is the basic building block, while in MEMS it doesn't have any building block. It have moving parts. This MEMS have moving parts and IC have no moving parts. Then the functions used in MEMS include biological, chemical and optical functions, while in IC only electrical functions are there. In MEMS, packaging is complex. In IC, it is well developed. Then MEMS manufacturing process. It includes bulk micro machining and surface micro machining. In bulk, it is used to produce micro machinery or MEMS. It refers, this bulk micro machining refers to etching through both sides of bulk material, that is either from front or from back to form the desired structure. In surface micro matching, the processes used in surface micro machining is deposition and etching. Then these are the MEMS manufacturing process, and basic steps for fabrication of this microelectromechanical system is deposition, patterning and etching. Then as a conclusion, microelectromechanical system are 1 to 100 micrometer devices that convert. It is used to convert electrical energy to mechanical energy or mechanical energy to electrical energy. the basic steps. The three basic steps for fabrication are deposition, patterning, and etching. Due to their small size, they can exhibit certain characteristics that their macro equivalents can't. MEMS produce benefits in speed. Its main advantages is speed, complexity, power consumption, device area, and system integration. These advantages or benefits make MEMS a great choice for devices in numerous fields. Thank you.